It's 9 because I multiply times this one, and this is minus 9. This is what? Less than 0. So we can actually say because minus 9 is less than 0, it means that the real root lies in 2, 3. So this is what I conclude, right? Because minus 9 is less than 0, it means that the real root lies in 2, 3. So actually, if you want to clear your English better, so it was all right, but you can do this just to give you a tip in English, of course. So, did you understand what I did? ¿Quedó claro lo que hice para demostrar dónde está, si está dentro o no la raíz?
Sí, profe. Sí.
Good. So now, to solve in Excel, I propose the following method. I'm proposing my own method because that's what I like. So I'm proposing this one. It's n, which is the iteration. A, it's my lower limit. B is my upper limit. Of course, F evaluated in here, and then Bn evaluated in B. And if you wanna actually check that the solution is in here, so you can actually see that if you multiply this one and this one, it's going to be a negative number. It's going to be negative, right? So I could say like my root is lying. This is my checkpoint. I would actually put it like my checkpoint. Why? Because I'm actually checking if my root lies in this neighborhood. Because I know that minus 9 times 1 is going to be what? Negative. It means that the root is still inside. And now I apply the bisection. So I apply the bisection. The bisection is going to be 2 plus 1 divided by 2. So it means it's going to be 2 plus 1 divided by 2. Ahora, si divido 2 más 3, perdón, si sumo 2 más 3, son 5 dividido entre 2, 2.5. Y por último, evalúo esta raíz que es xn más 1, la evalúo en mi función. Si se dan cuenta, mi función es este valor al cubo menos 9 por la raíz plus 1. Is this value 0? No, it's not 0. So it means like this is not the root. Si aquí no es 0, no es un valor correcto. Tiene que ser 0. And now one question would be, okay, professor, now what next? Aquí entra una decisión muy interesante. Este x se va a convertir en mi siguiente valor. Aquí entra una decisión que ustedes tienen que hacer en esta segunda iteración siempre. Yo tengo que decidir si quiero mantener este constante o este constante. Uno de los dos tiene que ser constante. Si se dieron cuenta, en el ejemplo que tengo aquí, el que fue constante fue 3. Y el que dejó de ser constante, ¿cuál fue? 2.5. ¿De dónde saqué este 2.5? Lógicamente lo saqué de este valor, de x. ¿Ok? Pero para variar y para que no creas que esto es magia, entonces, lógicamente, voy a cambiar mi decisión. Ok, so this is what I get. So I'm going to say that this is going to stay constant, and this is going to be equal to 2.5. ¿Qué pasó? Negative, negative. ¿Qué significa que tenga dos números negativos ahí? What does that mean that I have two negative numbers?
Que al multiplicarlos van a ser diferentes de 0, ¿no?
Van a ser mayor de 0.
Ajá, mayor de 0, entonces no entraría en la regla de que FA por FB, la función A por la función B tiene que ser menor que 0.
Exacto. O sencillamente puedes decir que la raíz no se encuentra en el intervalo. That's what it means when I say that the root is actually positive. The root always has to be less than 0. So that's why in this term, so I'm going to actually change to this rule. This 1a is going to become to 2.5, and this one is going to keep constant. So now it's constant. So I can actually evaluate it, and now it's negative, and this is positive. So this is going to be what? Less than 0. And then I do the bisection again, this one plus this one divided by 2. Si ustedes lo hacen ahí en casa, 2.5 más 3 es igual a ¿cuánto? A 5.5 entre 2 a 2.75. Y finalmente evalúo mi función f de x y me queda menos 2.95. We see that this one actually is approaching to a very low number, or is approaching to 0. So now what next? Okay, so this is my second iteration. And I'm gonna make this equal to 2.75, and I'm gonna keep this one constant. And then I'm gonna evaluate the function negative and positive. Negative and positive. So this is 2.75, sorry, and this one is constant. Okay, so it's still my rule or my checkpoint is correct. So I do this one. Oops, sorry. I just evaluate these two. And then it's decreasing. You see, it's decreasing again. So now my iteration number 3, I said that this is going to become equal to this one. And this one is going to stay constant, and evaluate again this. Is still negative and positive. Still okay. So I evaluate. Because this is still okay, I'd say number 4. This one is becoming equal to this one. This one, it's this one. And then I'm going to evaluate again. So you see, this is evaluated here. This is evaluated here. So it's still what? It's still okay. So I'm going to run it again. So number 5, this one is becoming equal to this one. And then 3 is going to be constant. What happened here? ¿Qué pasó ahí? What happened?
El valor ya no es negativo.
Ajá.
Exactly. The rule, the checkpoint, it's not correct. So now I have to actually change this. So now this is going to be the one that is going to be constant, and this one is going to become equal to the previous value. And then I see that this changed to negative and positive. And evaluate, and it's still fine. So in my 6th iteration, this one is becoming constant, and this one is becoming the previous value. Then I see that it's negative and positive, and it's still correct. It's still decreasing. My 7th iteration, I would say like this one, it's still constant, and this one, it's the one that is here. And then I evaluate the checkpoint, negative and positive. The checkpoint is correct, and then evaluate again. My 8th iteration, this is equal to the same number. This is equal to the previous one. And then I evaluate this one, and negative. So the wrong. So this is not anymore constant. So this is the one that has to be equal to this one. And this one is the one that is going to be constant. Now it's negative, positive. So we just go and clear this. You see? So good. So the 9th iteration, this one is the one that was changing, and this one is the one that is constant. Evaluate to change the checkpoint. Positive, positive, positive. So brown. So it means that this one has to be the one that is kept constant, and this one is the one that has to be equal to the previous root. So now it's negative, positive. And we evaluate, and if you see this, actually it's becoming lower, it's becoming, the error is becoming very, very low. So, and then finally my 10th iteration is going to become, this one is the one that is going to be constant, and then this is the one that is going to be the previous value, and then it's negative, positive, so negative, negative, so I got a positive number, it's wrong, so this is the one that is going to become this one, and this is the one that is going to become positive, right? And then I have this one, they're very similar, and then this is already approaching to 0. We can continue, but we have to check to 3 correct significant digits. It doesn't say decimal digits. When I say significant digits, it means that 3 of the digits are going to be the same. 1, 2, 3. 1, 2, 3. So these 3 significant digits are the same. No decimal digits. Here it says 2 decimal places, but here it says 3 significant figures. So in this case, we have 294 and 294. There are 3 significant digits, so that my answer is correct with 10 iterations. Ahora, por favor, sustituyan este valor aquí. O 2.94 en esta expresión, 2.94.
Me da menos 0.01391.
Okay, so that means that there is actually very low. So if we go to the answer sheet, for example, you see the answer sheet is actually the same thing. So is this?
Ahí me da menos 0.047.
Okay, it's fine because probably you use more than this, so it's fine. Doesn't matter. Very similar errors. If I do, si lo hago con 2.94 me da 2.94 al cubo menos 9 por 2.94 más 1 me da 0.047816 negativo. Entonces está bien
que yo le
todavía.
había metido el 2, ajá. Pero sí, ya con 2.94 sí ya me da menos 0.047816.
Exactly. There are 3 different conditions. First of all, 3 significant figures, or 3 significant digits. So I have 1, 2, and 3, and these 3 are the same. If I ask you for 3 decimal places, so you have to actually, this has to be 2.943, 2.943, because you need 3 decimal places. If I ask you for an error less than, for example, if I tell you that I want an error less than 0.0001, this is my limiting error, so this is not correct yet, because this is greater than this value. So I need to do more iterations to actually satisfy my limiting error. But for this illustration, it's perfectly fine. Okay, so now it's time for you to work. It's time for you to work, and then you will have to do this exercise 2 and 3. Please do it. By your own, and if you have any question, just let me know, please. I'm gonna be here with you. If you have any problem, don't worry, you will have. So think about this one. The second one doesn't have any neighborhood. You don't know the neighborhood. So you have to be aware of this because you don't know the neighborhood. So for this one, you have to propose a neighborhood. You can either do this in R as I did it, or you can use MATLAB because you already work on your assignment probably, or you work on the assignment I had and you can do it by your own, or just propose a kind of like a suitable range or neighborhood. Man, the classes, I still have 1 hour and I don't have anything more to do. So I think we're actually leaving soon after you work out with these exercises.
Profe,
Yes.
en el ejemplo 2, no nos está dando los puntos A0 y B0.
Exactly, that's what I said. You know, in this case, in the second one, you have to propose it. You have to propose it using the graphical method. Puedes tú graficarlo, como ya sabes en MATLAB, lo puedes graficar
Okay.
y sacar tú.
Y ya en base a la gráfica saco A y B. Ok, perfecto.
Exacto. Por eso es que va acumulándose. Esta materia siempre se va acumulando los conocimientos para que ustedes tengan herramientas para usarlo en posteriores clases. So what about the students? Did you went to the bathroom or something? I just see 2 people. Well, actually 1 people. So what about the others? One more. What about the others? Please, por favor, todos los demás pongan su cámara para que esté yo viéndolos y sepa que están haciendo la tarea, ¿no? Porque si no, pues imagínense, yo aquí me voy a matar esperando que ustedes terminen y pues no se vale, ¿no? Solamente veo a 6 personas, 7 ahora, 8. So when you tell me if you already copied the exercises, I can just show you this one so that you will find the same strategy to solve this exercise. But you let me know when you copy all these exercises. Díganme cuándo lo copiaron para que yo cambie a la otra de Excel y ustedes puedan, pues, basarse en la misma lógica que yo me basé, ¿no? So I see 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, and I have a lot. I have how many students in this class? So this is lista de asistencia. There are some people. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we have everything. So no vino Tolentino, Girán Josué, Andy de Jesús, ni Jonathan. No vinieron ellos. That's fine.
Profe, hace rato que no tenía la cámara, es que sí había ido al baño, disculpe.
That's all right. You can go to the bathroom, but I just wanted the camera, especially in this time, because I need you to see you. I need you to know that if you're doing the exercise or not. So al parecer en Acayuca, de las 10 de la mañana hasta las 5 de la tarde se suspenderá energía eléctrica. ¡Wow!
¿En dónde dijo que se fue la luz, profe?
Se va a ir en Acayuca de 10 a 5 de la tarde, dice.
Igual y por eso una compañera no se pudo conectar.
De hecho, es Esperanza, pero no sé si está así. Aquí está, mira, Tolentino. Okay. You can watch the class later. On my YouTube channel. I mean, this is good because if you go to my YouTube channel, you can also watch the class. Remember that it's already recorded. If you have any problem, question, or something that you want to verify again, so you can watch it on my YouTube channel. It's there. It's on the playlist Numerical Analysis. Probably that's why many people is not coming to the class, because they just want to actually watch it later. I don't know. So, ¿ya copiaron los ejercicios 2 y 3 para que les ponga el Excel? ¿Ya lo copiaron?
Sí, ya.
Ya, profe.
Ok, entonces les pongo el Excel para que vean la lógica, vean las columnas, vean cómo realicé. Si tienen alguna pregunta, también vayan haciéndolo, ¿no? De todos modos, al final de la clase, yo les voy a resolver y les voy a mostrar el ejercicio para que ustedes vean cómo se hicieron, ¿no? Les voy a dar de aquí a las 11, vamos a darle a las 11:20, ¿no? Más o menos. Sale 10 minutos para que hagan un buen progreso. 11:25 vamos a ponerle, para que ustedes progresen. Si tienen preguntas, recuerden que aquí estoy.
Profe. Profe.
Yes. Tell me yes.
Yo aún no tengo MATLAB descargado. Lo iba a descargar, pero en este instante, ¿será que puedo agarrar los intervalos del ejercicio que usted hizo? El de 2 y 3.
Yeah, I'll give you, well, for this one, for the second one, it's, let me just check the slide. It's actually, yeah, I'm gonna give you the limits. They are in between 1.5 and 1.6. 1.5 entre 1.6. El segundo ejercicio.
1.5 y 1. Ok, gracias, porque es que, bueno, voy a aprender el MATLAB, pero ya se alentó mi computadora bien feo. De hecho, no ha cargado, ahí sigue cargando.
Okay, that's all right. Don't worry. So just I'm gonna give you for the sake of the class, but remember for the exercises you will have to do everything by your own.
¿Qué puntos había dicho el profe para el segundo ejercicio?
1.5 y 1.6.
Ok, gracias.
If any of you have the answer of the exercise, let me know to check the answers and I will tell you if you're wrong or you have a mistake. Either way, I will actually do it at the end of the class. Don't worry.
Profe, yo tengo una duda, pero es sobre Excel. ¿Cómo representa el exponente en Excel?
I'm sorry, I didn't hear you. You got a lot of noise. Could you repeat please the question?
Que le repito la pregunta.
Yes, please.
Que en Excel, ¿cómo represento el exponente? O sea, es que no sé.
Yeah, that's all right. Don't worry.
Creo que es la primera
So,
vez que meto exponente.
You use this sign, this one. This is the exponential. Oh, you mean the exponential of this function, right? This one. This. So you have to use the x.
Ok, perfecto. Ok, perfecto. Gracias.
EXP. Yeah, no problem. Good question, by the way. I'm gonna give you 5 more minutes, so you will have until 11:27 to finalize the examples. Don't worry if you don't finalize it. I will do the exercises by my own. So the point here is for you to have the idea of how to solve it. So you will have the time to do it by your own when you solve the assignment. Don't worry about this. And you're also gonna have the video to watch it later.
Profe, tengo otra duda.
Yes, go ahead.
Ya empecé a hacer la sustitución de los valores en la fórmula de Excel. Entonces, en la iteración 0, para sustituir el valor de A y de B para la función A y B, la función A y la función B me dan positivo, pero no sé por qué.
So I don't think it's actually positive. So you have the two values, 1.5 and 1.6. So if you analyze here, here is you have the exponential of this of 1.5 minus 3 times 1.5, and I got a negative number. And if you see in the second limit, I got exponential of 1.6 minus 3 times 1.6, I got this value. So the multiplication of these two, it's actually negative. So the exercise, it's fine. So the root is inside the limit.
Perfecto. Bueno, ahorita lo checo. Gracias.
Yeah, no problem.
Profe,
Yes, go ahead.
¿el Euler era elevado a la 3 o a la X?
Oh, to the x, you have to use the x value, which is the limits of your neighborhood.
Ok, gracias.
No problem. Thank you. Okay, guys, are you done with the exercises? ¿Terminaron los ejercicios?
Sí.
Sí, profe. Sí.
Okay, great. I was in a phone call with Dr. Alcala, so that's why it took me some time. But so do you think it's actually, do you think you need me to actually verify the results to do it by myself? Did you get these results? ¿Quién quiere que lo haga desde cero? Lo puedo hacer en esto lo que falta de la clase. Si quieren lo hago, por los que no entendieron, no pasa nada, lo hago. O ya todos tienen estos resultados.
¿Sí
Yo-
podría
Yo no, profe.
explicarlo, profe?
Yo tuve problemas con el Excel porque no, o sea, yo estoy haciendo uno por uno, como quien dice, copiando, escribiendo cada fórmula, ¿no? Pues, pero a donde voy en la celda 4 y pues tengo lo mismo que tiene usted,
Yo ya
pero
acabé,
voy uno
Okay.
por uno.
I'm going to actually do it very quickly. I'm going to do it quickly for you to get, not very quickly, of course, but to get the general procedure. It's like exactly the same what I did in the previous exercise. So I'm just going to do it and you do it by your own, because I'm going to give you also exercises. You see this one, and then you will have these exercises to actually do it at home. Okay. So I'm going to start doing the other examples. I'm going to start with this one, the exponential, because this is the second example. So essentially, I'm going to actually delete all this. So I'm going to delete all this, and then I already gave you the limits, 1.5 and 1.6. I got evaluated the limits in the function, so the exponential of this number minus 3 times the same number. I got this evaluation. I got the same line, of course, the same number of columns as in the beginning. This one, this is the checkpoint, remember? This is the checkpoint. So I got this one, and then it's exactly the same. So I'm gonna do is just number 1, and then of course I have to decide. So this is 1.5. It's okay, minus positive 1.5. I'm gonna just I'm gonna use this one equal to this, and I'm gonna keep this constant. This is my decision. This is only a decision, and then I'm going to evaluate everything here. So I see it's positive, so I have to actually modify this, and this is going to be the one that is going to change, and this is the one that is going to be constant. So now it's negative, positive, it's fine. So I continue, so this is going to stay constant as well, and this is going to stay, this is going to be this one. And I evaluate the function, negative, positive is still fine. So 3 times the same one. So this is going to be, again, the same number. And this is going to be the one I have here. I'm going to evaluate again. Negative, positive, it's still fine. 4. This is going to be still the same. This is going to be this number. And I'm going to evaluate the values. Now is negative, negative. Here I have a problem, so I have to actually change this one, and this one is going to be the one that is going to be the previous value, and then this is going to stay constant. Okay, negative, positive is fine. My 5th iteration, and then I have this one is the one that is going to be changing again, and then I have this one. And I'm going to check it, negative, positive is still the same, my 6th iteration, and then this is going to be the one changing, right? Yes, and this is the one that is going to stay constant. And then it's negative, positive is still good. And finally, my iteration 7th, I'm gonna actually put this one here, and then this is going to be the same number, and I'm going to evaluate the function. Is positive, negative. So the exercise tells me you have to correct to 2 decimal digits. I have 1, 1, 1, 5, 1, 5. So it's now correct because I have 2 decimal digits of my solution correctly. So I have the solution. As you see, there is 3.8 to the times 10 to the power minus 5. So it's a very low error. and this is the solution for the second exercise. Okay, so and then the solution for the second exercise, this is the exercise with the tangent. So also I evaluate my tangent in the limits that I provided in the exercise, and with 2, it's a negative number, tangent of x 2 plus x. This, remember that Excel, it's already in radians. You don't have to do anything to change the values. And then the same thing, right? So with the upper limit. So I do the iteration, so it's negative, positive. So I'm gonna just put this one with the next value, and then I'm gonna keep this constant, keep the constant. So here is positive, positive, wrong option, so it's not good. So this is the one that is gonna stay constant, and then this is the one that is gonna be changing. Oops. Oh, what is this? This is the first time I see this in my life. So I'm gonna change this one. So right here. So it's negative, positive, positive is okay. So my second iteration, this is gonna stay constant. This is gonna be the one that is gonna be changing with this value. And then I'm gonna evaluate once again. This is negative, negative, so I have to actually change it to be the previous value, and the second, or the upper limit, is going to be the same one. And then I'm going to do the same for this one. Here and here, it's going to be the same one. And then I'm going to evaluate once again, positive, positive, wrong, so I have to keep this constant. And I have to change this one to the previous value. And then negative, positive, it's okay. So I'm gonna go to the iteration number 4. This one is constant, and this one is the one that is gonna be changing. Negative, positive, good. So 5th iteration, so this is the one constant, and this is the one changing to the previous value, and negative, negative, so it's not good because this doesn't meet the checkpoint. And then this is the one that is gonna be changing, right? So to the previous value. And then this is gonna be constant. So we're almost there, positive, negative, iteration 6. And then this is the one that is gonna be, it's gonna take the previous value. This is gonna be constant again. Then I'm gonna do this, and then positive, positive, not good. So now this is the one constant, and this is the one taking this value, right? There you go. So the error is very low already. So in my iteration 7, and then I have this one is constant, and this one is the one that takes the previous value, and I evaluate once more, and I got, so first of all, 2 decimal places. So 2 decimal places, 1, 2, even 3 actually, I got 3, 1, 2, 3, 1, 2, 3. So I got 3 decimal places correctly, and I see that the error is 0.0001, well, actually the difference. So it's not very difference from 0, and that's how I solved it using the bisection method. So you can see that this is actually a pretty straightforward method. So this is essentially what we did in the class. You already did it at home. So it's a very easy exercise, and I got the same answers as I was, in the previous classes. So it's not anything changed, and that's it. So this is the bisection method, and as I told you, once we solve these 3 exercises, I think you're ready to actually solve these 9 exercises. So this is going to be posted soon in Eminos, and also the previous assignments. Don't worry, I'm going to give you enough time to do everything you have to do for the second and third assignments. So this is going to be the 4th assignment. So you will have time, don't worry. And then, you know, just if you have any questions, you have the WhatsApp chat, or you have the forum in Aminus. And I think I'm going to stop the class, the recording class here. So the ones that the ones in the afternoon, you will have to do the same at home, and you have to also send your questions if you have. Stop recording, and